Hi guys, so welcome to the lab for this week. And this week you guys are going to be looking at the Earth's atmosphere and seasons. And so I won't really have a PowerPoint. I'm just going to go through the lab and kind of break down for you guys what you'll be doing and explain a few things here and there. So first off, you'll have the introduction, and you're going to be doing this intro exercise to essentially to define the different levels of the atmosphere. So Earth's atmosphere is broken up into a few different levels. You're going to be looking at these main four: the troposphere, stratosphere, mesosphere, and thermosphere. So what you'll be doing is you're going to be more or less running four types of flights, balloon flights, air balloon flights on this program. And you're going to try to get different data readings that will have different readings for temperature and pressure at different elevations. And long story short, just to kind of give you a visual, you're going to be doing it through this software. And click layers of the atmosphere. And so this is what you'll be doing. So here's your air balloon, and you're going to set a high sample and a low sample. And what you're going to do, so you're trying to find a change. You're trying to find changes in temperature and in air pressure at these different elevations to define the different atmospheric layers. And then the introduction, the directions kind of break this down for you even more. But long story short, you're using 4 different flights, which give you 4 different readings. You're going to play around with at what range do you take your samples from. So you set your range, you launch balloon, and you'll get 4 data points somewhere. You're going to do that 4 times, and it's going to give you 16 data points. And you're going to look at them and try to find a pattern or a trend that will help you define the different layers of the atmosphere. So that's more or less that part. And once you do find that, you're going to try to use your readings your data points. You're going to try to use your data points to answer the following questions. So if you have a reading at 10 kilometers, you're going to try to find the pressure. So if you have a data point with 10 kilometers is right here, you're going to pretty much find the air pressure at 10 kilometers for that question. And same with the next one. Well, more or less. Once you have the pressure for that, you're going to find at what altitude do you have half of that pressure. So once you get that, you're going to look for an altitude at half of that pressure. So you're going to see what altitude do you get half of 1013 millimeters. And then, yeah, so after that, again, just looking at your data points, you want to look for a trend, and you're going to look for changes in the air pressure and temperature at which elevations. So, for example, does the air pressure, does it go up, then down, then up and down? Does it gradually increase? Does it gradually decrease? Or do you just see a straight line in the air pressure as you go higher up? So you're going to look for those trends, and those trends will help you define these boundaries. So these questions are asking for the pauses, the tropopause, stratopause, mesopause, and thermopause. And what those are the boundaries between the different spheres. So between the tropopause and the stratopause, you have the troposphere and the stratosphere, you have the tropopause. Between the stratosphere and the mesosphere, you have the stratopause. Between the mesosphere and the thermosphere, you have the mesopause, and so on. And so looking at what elevations do you see those major changes on your graph, that'll kind of help you define what altitudes those are at. So hopefully that makes sense. If you see a gradual change in air pressure, maybe you see a long increase at about 20 kilometers of altitude. So long decrease. Well, then maybe that's one of your boundaries. That's either going to be your tropopause or your stratopause. So things like that. I'll even do an annotation for that actually. So yeah, say you have data points that go here. So you have a data point that goes here, and then it goes here, and then it goes here, and then here. Then all of a sudden it goes here, here. Well, yeah, so here, here, then here. Oh, that's great. Well, so yeah, so say you have data points like this that do this trend. Well, right here, you're gonna have a change in a barrier right here. So here's gonna be a barrier. So here's gonna be one of your spheres, and here would be a barrier, is because you have that markable change. And so that's how you're going to define it. This is just an example. This is not the correct answer or in any way, but yeah, that's just an example. Next, so once you define those, pretty much, you're also going to look at what air pressures do you see those changes? What temperatures do you see those changes? And so on. So just make sure you're keeping an eye on that and make sure you have those 16 data points to really give you a good idea of where you see those changes in the layers. And then kind of again, almost reiterating what you did, you're just going to fill it in this table. Now, next up, the next part is going to be about the ozone. And the reason the ozone layer is important is because it does protect the Earth from pretty harmful UV rays, UV radiation from the sun. And that's the reason you've probably heard of like a hole in the ozone layer, if you will. This section will kind of help you understand it better. The ozone layer is helpful to pretty much life on Earth because it does protect, from powerful UV radiation from the sun. And that if without that ozone layer, without that protection, people and plants and animals could suffer greatly. So what this section covers is what is ozone, what's good ozone, and what's bad ozone, more or less. And this is here too for you to read. You won't really have too many questions on it, but it's definitely good to know, and you definitely do want to learn it. Now, next up is your next question. You're going to pretty much read ozone layers, the ozone layer, if you will, during a certain time. So you're going to look at this animation, and what the colored section is, the green color, that's your reading. That's the highest values of ozone, pretty much. And you're going to pretty much look at what months are those values the highest. And if you need some background on how to read it, question 14, you also use this for question 14, but this explains it pretty well. Pretty much from about green upward, from green to yellow to red is higher readings. Anything below that is kind of lower. And so for question 10, you're going to look at that animation and see which months have the highest reading of ozone in dots and units. These are dots and units. What months do you see the most color above Antarctica, if you will? And that's going to help you answer that question. And then the inverse of that, you're going to see what months are the lowest. So what months have no ozone reading above Antarctica, above the Antarctic ocean. So for question 10, you're looking for color, you're looking for green, red, yellow, you're looking to see which months have those high concentrations. And then for question 11, you're going to look for the absence of that color. You're going to look for which months have the lows. And then next up, you're going to use this website. And it's the same website for question 14. And so you're going to look at the last 7-day total of the ozone images. So you're going to look at from September 5th through September 12th. And you're going to try to see the range, if you will, of dots and U's over the Antarctic of that 7-day period. And then next you're going to use the range of the range of ozone, of the ozone density, if you will, above the rest of the map, above the rest of the world that excludes the Antarctic. So for question 12, you're looking at readings over last week of ozone over the Antarctic. And then question 13, same time period, with just the rest of the map, excluding the Antarctic. And then after that, you're just going to, again, question 14, you're going to kind of read over this and it'll give you kind of the answer what substances are pretty much bad for the ozone, what substances are hurting the ozone layer and breaking it up. And that's just a quick reading on question 14. Now, question 15 on pretty much the rest of the lab. The rest of the assignment is going to use this website. And what this does is it pretty much shows you the Earth in terms of hemispheres and latitude using the equator as a reference. So the next few questions you're going to look at, so what hemispheres are these towns in? What hemispheres are these locations in, north or south? The Earth is divided into a northern hemisphere and southern hemisphere that is divided by the equator. And what's really cool about this website is you'll be able to see the Earth's rotation at different tilts, at 0 degrees, 23 degrees, and you're going to look at the length of day. And the website's going to tell you the length of day is going to be defined as the amount of daylight within for that area in a day, if you will, the length of daylight within a 24-hour period. And that's going to be a day, if you will. And you'll notice changes. Not everyone's going to have the same answer. Some are going to have different. And even at the same towns, you're going to get different readings for different times of the year. So just play around with that on the website. Again, this kind of goes through how to break it up, how to show it. And these two questions are asking for a ratio. So you're going to, again, play around with the interaction on the website. And you're going to find the ratio of daylight to pretty much darkness, to absence of daylight in Chicago in December. So like how many hours out of 24 hours, how many of them are daylight and how many of them are not? You know, if it was 2 hours of daylight, I mean, 22 hours of darkness, which would be, 1 to 11. That's just an example. That's not the answer. But that's just an example of what you're going to try to look at with the Earth set to, at Earth, during December. And then once you look at it in December, you're going to look at it in June. And you're going to do the same thing, a ratio of daylight to darkness. Maybe this time, say it's 8 hours of daylight and, 16 hours of darkness. And that's a, 1 to 2 ratio. That's a, I guess 33 to 66 if you want to make it 100. So that's what you're going to do for those two questions. 18, you're going to again, still looking at Chicago, put the Earth's tilt to 0 degrees. It's going to start off at 23 degrees, which is what the Earth is tilted at on its axis. You're going to tilt it to 0, and you're going to see how that affects the proportion of daylight to darkness. You'll see if there is a change, there's no change, and so on and so forth. And then next, you're going to just pretty much consider the seasons of Chicago at those times. And then you're going to look at the Earth. So there's going to be a setting where you can show the equator and you can show the different boundaries. You're mainly going to focus on the equator. And then once you set it to this, once you pretty much see the equator, you're going to see a shaded area and then a lit up area. What this question is asking is which hemisphere has more daylight, which more sunlight, if you will, compared to darkness. You'll see the whole Earth, and part of it will be lit up, part of it will be shaded. And pretty much this question is asking which hemisphere has more daylight, has more of the lit up area compared to the dark area. And that's what this question is asking, and you'll be able to see it on the interactive. So yeah, and then the following questions are kind of summary. And then question 23, you will see a distance label on the interactive right here. And so it's going to ask what months, pretty much what month is that labeled, what month is that distance the shortest? What month is that distance the longest? And so that question is pretty much trying to show you what months the Earth is closest to the sun and what month is it furthest from the sun. And that'll kind of tie into seasons and whatnot, which is what 24 is. 24 is going to kind of be a cumulative of that as well. And then this 25 is just kind of another review just to hit it home, whatever you learned, if you will, about the seasons. So that's pretty much it for this lecture. Again, most of it are going to be in the websites and in some of the animations and whatnot. Just trying to be a bit more interactive than just a PowerPoint lecture and then do the assignment. Again, if you have any questions, please reach out to me. Email, Canvas, I'll get back to you as soon as I can. And yeah, hope you guys have a great week.